I'm going to do a set of videos now about linear dependence. I'm not going to do linear dependence on vectors in R2, that's too easy, but I will mostly do some exercises with matrices and polynomials. Okay, let us say we have a matrix A and another matrix B, where A is 1, 2, 3, minus 1, 0, 2, and B is 2, 4, 6, minus 2, 0, 4. Now the question is, are these matrices dependent? Well, of course they are, because B is nothing else but A multiplied by 2. Okay, so if we multiply A by 2, we will get 2, 4, 6, minus 2, 0, 4. Okay, so A and B are linearly dependent. Matrices A and B are linearly dependent. Okay, let us say we have three vectors, 1, minus 2, 1, 2, 1, minus 1, and 7, minus 4, 1. Let us see if these three vectors, if they are linearly dependent. Okay, we are going to do this two ways. Okay, one is we put vectors here, 1, minus 2, 1, plus 2, 1, minus 1, plus 7, minus 4, 1. Okay, and we check if they are all equal to 0, but we have to put, let us call it the scalars here if you want, x, y, and z. Okay, now you do all these calculations. Okay, so first you multiply x minus 2x, x, 2y, y minus y, 7z minus 4z, z, and see if all this is 0. Now if you add this one, and this one, so x plus 2y plus 7z, that will be 0. Okay, so you do this system of equations. Okay, and now, and if you do the very simple calculations, you will get to this. Okay, so the system is in echelon form, right? So it has only two non-zero equations. Okay, so the n are 2, but you have three unknowns, x, y, well, not the n, or the n, I always call n the variables. The variables are 3. Okay, the variables are 3, right? So the system has a non-zero solution. Okay, so the original vectors, they are linearly dependent. These vectors here, they are linearly dependent. Okay, rank 2 and variables 3. Okay, so we have a degree of indetermination here. Okay, now another way. So let me call this method 1 and let me call this method 2. Well, the second method is really easy, right? You just form the matrix whose rows are the given vectors, and you reduce to echelon form. Just use the elementary row operations. Okay, so of course I'm going to, so this 1 to 7, so you will get 1 to 7 here, right? 1 to, is this a 7 here? Yes. Well, let me do some quick calculations here. 1 minus 2 1 0 5 minus 3 0 0 0. That's what I'm getting. Well, let me see. Well, yes, minus 7 here, right? Minus 7 plus 0, minus 7 you get 14, right? Okay, and then minus 2 here you get 0, minus 2 you get 4. Okay, yes, okay. Well, and here is very simple, since in the echelon form you have a 0 row, right? So that means that the vectors are dependent. Okay, of course this method is really quick, right? You just put the vectors on a matrix and then row reduce and check if you get the same number of variables as independent lines, and done.